So today we are going to solve, what's today? The 10th, right? 10-10. Okay, we're going to solve systems of equations by substitution. I'm hoping you remember a little bit of this from algebra. But if you don't, that's okay. We'll go back through it again, okay? So, before I start, just a quick little picture, right? Just a quick little picture. So all of these problems that we were doing in this entire chapter for this whole week has to do with just really finding where two lines intersect, right? That's the answer. The answer is going to be where they intersect. And of course, if they're parallel, then they don't intersect. The answer is the empty set or no solution, right? If they're the same line, we know that then the answer is all real numbers, right? But what we're really doing is trying to find out where two lines intersect. Now, there's a real disadvantage to graphing for a lot of reasons. One, sometimes the graph is so big it's off the graph, right? Sometimes the answer might be fractions or decimals, and if you're going to try to get those answers by graphing, that's really tough. So there's got to be a better method, a more accurate method. And sure enough, we're going to do it by substitution today. Okay, so how does substitution work? Well, when I do substitution, the first thing I do is I like to write these side by side. Okay, so I'm going to write my y equals x plus 2 and my x plus y equals 8. Okay, I'm going to write them side by side. For me, it just is always a little bit easier if I do that because I want room to work. And then I like to put my little squiggly line in between. Okay, so substitution is like this. What I want to do is put x plus 2 right there. I'm going to put x plus 2 right there. Well, here's why. Y is equal to x plus 2, right? Y is equal to x plus 2. So instead of writing y, I can substitute it, right? I can substitute what y is equal to. So what I'm going to do is take this x plus 2 and we're going to substitute it in for y. It's called a substitution because that's what y is equal to. It's equal to the x plus 2, so I'm going to put that right in for y. It's a substitution, okay? So I'll rewrite this equation. Instead of x plus y, I won't write y. I'm not going to write y at all. I'm going to write what y is equal to, which is a x plus 2, because that's what y is equal to, okay? Now, what I've done is allowed myself to solve for x, because this second equation here is all in terms of x, right? I put the parentheses. I don't really need the parentheses because there's nothing in front, right? But I just put the parentheses to show the substitution, okay? So first of all, thumbs up on why I put x plus 2 here. Everybody get that? Okay, everybody, right? Everybody understand why I put x plus 2 here? Because that's what it equals. Y is equal to that, so put there. Okay, now let's just solve. So I have an x plus 2 equals 8. I just dropped the parentheses. I didn't really need the parentheses. 2x plus 2 equals 8, right? Minus 2, I'll have a 2x equals 6, right? Divide by 2, x is 3. Okay, now that is the x coordinate of the point, right? Remember, we're trying to find a point. So what I need to do is substitute again. So to substitute again, now I'm going to take my 3, which is what x is equal to, right? X is 3. So instead of writing x right here, I'm going to write 3 because that's what it says. X is 3. So let's put 3 right here. So we substitute again. Since we know what x is, let's put 3 there, 4x. We're going to substitute again. So I'll put this right there. And I'll rewrite this as y equals 3 plus 2, or y equals 5. Now, awesome. We got the answer, but the answer is, slide it back down. The answer really is a point. We didn't graph it. Nice. We didn't have to graph. We just needed the answer. And it is a point, right? So the point we found was at 3, 5. Okay. Thumbs up. Okay, not too bad. I think you guys have done this before, right? A couple of different times. Okay, good. Okay, example 2. Okay, same type of process, right? I like to write them side by side. If that annoys you, then okay, too bad for you. I'm going to do it anyway, okay? So I like to write them side by side. Y equals 2x plus 5 and 3y plus x equals 6, all right? And I write them side by side so that I have room to work. I like to have room to work, okay? So, all right, so instead of writing y right here, I'm going to write 2x plus 5. I'll write the 2x plus 5 right in here for y because y is equal to 2x plus 5, so put this right there, okay, because that's y is equal to, okay? So I'm going to take my 2x plus 5, I'm going to put it right there, okay? Makes sense? Okay, it's just a substitution. Instead of writing y, we write what y is equal to, which is a 2x plus 5. Okay, so then I'll go 3, and I'll go 2x plus 5 plus x equals 6, okay? All right, now my second equation is all in terms of x. So solving for x is pretty easy, right? So I'm going to have a 6x plus 15. Now remember, I got to remember to distribute because I'm solving this times this times this, plus an x equals 6. How am I doing? Okay? How's my pacing? Am I going okay? I'm not going too fast? Okay, let me know. 7x, you guys okay with 7x? 7x plus 15 equals 6, right? Minus 15, 7x equals, what's that, 9? Okay. Divide by 7, huh? Yeah, it is negative 9. Divide by 7, and x is equal to negative 9, 7. So here's a reason why, this is a great example of why you really want to use substitution. You're not going to get that answer by graphing. I mean, think about it. Are you going to get that answer by graphing? Negative, or it's negative, or, you know, negative 1 and 2 sevenths. Probably not. If you had to graph two lines, and we needed the exact answer, you're probably not going to get that answer, right? But we got the answer by substitution. It wasn't too hard. Okay, now, to get the y value, let's take and plug this up here, right in for x, right? So I'm going to rewrite this as a y equals 2 times a negative 9 sevenths plus 5, right? Thanks, Simon. Almost missed my negative. Appreciate the help. If you don't like fractions, that's okay. That's like 2 over 1, right? So I have y equals a negative 18 sevenths plus 5. Let's see, that's a negative 2 and 4 sevenths, right? Plus 5. Okay, I do a little fraction, sorry. I know sometimes we have to do fractions, but let's see, 7 goes into 18 two times, which is 14, right, with 4 left over. Everybody okay with that? 7 goes into 18 two times with 4 left over, okay. And then if I add these two, I'm going to get a positive 3 and positive 2 and 3 sevenths. Sorry, positive 2 and 3 sevenths is what y is equal to. Okay. So again, one more point. You're not going to get that answer by graphing, are you? So we had to have another technique. And I kind of like this for one reason more than anything, and that is graphing. It's kind of tedious, isn't it, right? Get your graph paper, draw a line, solve for y, get it. So graphing is a little tedious. Not only that, but it's inaccurate. It's inaccurate. So we get this answer here of negative 1 and 2 sevenths and 2 and 3 sevenths. That's the answer. That's the answer. Represents where two lines would intersect. We'd never get that point by doing it by graphing, okay? Megan, go ahead. Okay. All right. So there's some fractions in there. I guess you could have used a calculator also in decimals, but we got exactly the answer because we were able to do it in fractions, okay? Okay, you guys ready to turn the page? Okay. Thumbs up when you're ready to turn the page. Okay. All right, I'm going to turn the page. Let's take a look. Okay, on the back, example 3, okay? So again, by substitution. So let's write them side by side. And again, if that annoys you, too bad for you. I'm going to do it anyway. 2x plus y equals 6. I know some of you really smart kids skip steps. I'm not as smart as you, so I don't skip steps, okay? I just show every step, right? So y minus 8x equals 1. Now, here's the thing on this problem is that we can't really substitute yet. Not yet, because you got to either say y equals blah, 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 or you got to say x equals blah, 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 because we've got to make a substitution, right? So either we have to say some y equals blah, 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 or some x equals blah, blah, blah. So when I look up here, you can do either one. You can either solve for x or y, okay? A little note, solve for x or y. You can do either one, okay? It doesn't really matter. I always look for the easiest. That's an or. That's really sloppy. Solve for x or y. There we go. A little less sloppy, okay? So it doesn't really matter to me, but when I look up there, sure seems like the easiest one to solve for would maybe be here. Just add the 8x. You guys okay with that? So you have to have either x equals something or y equals something to substitute. You could bring the 2x over. You can do it here and have y equals this too, right? Both will work. It really doesn't matter to me, but I think this is easier. That way we get rid of the negatives. You okay with getting rid of the negatives? So here's my idea. I'm going to bring the 8x over. And I'm going to have a y equals an 8x plus 1. Because I added the 8x, right? Just add the 8x, so it brings it over. Now, when it comes to substituting, I can put this 8x plus 1 over here, right? So you can substitute either side. As long as you have something equal, you can plug it in, or substitute it in, okay? So I'm going to go, okay, 2x plus 8x plus 1 equals 6. So really I just put my 8x plus 1, I put in for y, okay? I don't need the parentheses, I just put them in there so you'd see it. Here's y, this is what y is equal to, boom, put it there, right? Here's what y is equal to, 8x plus 1, I put it there, so there it is. So right, I got there, okay? So then we'll solve. So I'll have a 10x plus 1 equals 6, right? Minus 1, 10x equals 5. Divide by 10, and x is 1/2 or 0.5, right? Again, another one of those decimals that's kind of hard to find on a graph, so it's good to have another technique. Okay, so this is what x is equal to. Let's plug it right there, okay? So we'll substitute the other side, okay? Let's plug it right there. We'll have a y is equal to 8 times 0.5 plus 1, okay? Just substitute because that's what x is equal to. So instead of writing x, let's write 0.5 because that's what x is equal to, right? So now, that's like half of 8. What's half of 8? Half of 8? Half of 8?
3. 4.
Thank you. 4 it is. Y equals 4 plus 1. You have to know, Kenzie. Y equals 5. So our answer, remember, flip the page for a second, I'll flip back. We're looking for where two lines intersect, right? So our answer has to be a point. 0.5 comma 5. Okay. Almost done. Am I doing okay? And you guys have seen this before, right? You've done this before, right? This is just a matter of just reviewing it. Okay, my little freshmen are doing it right now. They're not happy about it, but they're learning because, you know me, we're gonna learn it. We're gonna learn it. We're gonna learn it. We're gonna learn it, right? Okay, example 4, same thing. I write them side by side. Y is equal to 8 minus 2x, and I'm gonna write a 6x plus a 3y equals negative 15. Okay, I like to write them side by side. Okay. All right. So I can substitute pretty easily because the y is already solved for. So let's take this and plug it in for y, okay? All right, how does that look? So instead of writing y right here, this is what y is equal to. So take this, what y is equal to the 8 minus 2x, and put it right there, okay? Put it right there because we're substituting, okay? So let's see, I got a 6x plus 3 times 8 minus 2x equals negative 15, okay? How am I doing? All right, I've got a 6x plus 24 minus 6x equals negative 15, right? Oh, no. Something terrible is going to happen. I have no x's. And then I get this crazy thing like 24 is equal to negative 15. Not in my math class. Not in my math class. 24 does not equal negative 15. No way. There's no x's. So what's my answer? So there's no solution. So what do we know about if we know that answer, what do we know about these two lines? We didn't graph them. They're parallel. You guys agree? So no solution. Okay. Now, if you got, real quickly, if you got an answer, it's just hypothetical. Hypothetical. If you got an answer like maybe 24 equals 24, no x's, or maybe you got an answer like maybe negative 15 equals negative 15, or maybe you got an answer like 3 equals 3, and all the x's are gone, you'd know they were the same line, because you could have canceled out everything, and that would be all real numbers. But in this case, that is definitely untrue, isn't it? That is not true, so it's no solution. Okay? All right, so before we start our homework, okay, I want to talk to you about the egg drop. Let me stop my recording. Stop my recording.